My name is Jonathan Hicks and we're finding the gradient of a straight line. Now you need to understand, broadly speaking, what a gradient is. If you don't know what gradient is at all, go and watch the gradients video that I've done. That'll just give you an overview. But in this video I'm just going to show you the technique for how you find the gradient of a given straight line. So if we start with an example, typically you'll have a set of axes. So x, remember, goes along the bottom, y goes up. And you'll be given a straight line on this set of axes and you'll be told some information about it. So you might be told, for example, that it crosses the y-axis at 2. You might be given a point on the line. Let's imagine this point is 4, 4. And they'll ask you to find the gradient of the straight line. Now the way you find the gradient for any straight line is the first thing you have to do is draw a right angle triangle that sits underneath the line. Now you can put the triangle anywhere you like in theory, but if you've been given information, specific information like this point and that point, you want to connect your right angle triangle to those points. So in this example, I'm going to draw my right angle triangle like that. So it sits underneath the line, it must touch the line, and the slanting bit of the triangle is always part of the line itself. Now in general, to find the gradient for any straight line, it's defined to be the height of the right angle triangle that you've just drawn, the height of the triangle, divided by, so this is like a giant fraction, the width of the triangle. So to find the gradient we have to find the height of this triangle and we have to find the width of that triangle, and we just divide the height by the width and that gives us our gradient number. You just need to remember that if the line goes uphill, the answer will be positive. But if the line slopes downhill, you're going to get a negative answer. That catches a lot of people out, so do be careful. So in this case, the height of our triangle. Well, knowing that this point up here is 4, 4, just to fill out a little bit of extra information here, that means that the x value here has to be 4 directly under the point, and the y value across from there is going to be 4 as well. So I'll just fill those out. It'll just help us to see a bit more clearly what's going on. So we need the height of our triangle. This is obviously 0 down here. Now be careful, the height of the triangle is not where the top is. Yep, the height is not 4. The height of the triangle is the distance from the bottom to the top. So in this case, the triangle starts at 2, it goes up to 4, so the height of this triangle is 2. What I normally do is write the height next to the side that it belongs to. So the height of our triangle is going to be 2. I'll stick that on the top of a fraction. The width of the triangle then, so that's the distance from the left hand side to the right hand side of the triangle. Well, it starts at 0, it goes across to 4, so the width of this triangle is going to be 4. So our gradient is 2 divided by 4. It's a fraction, check if it cancels. It does. 2 goes into 2 and 4, so in this case it will cancel down to a half. So the gradient of this line here would just be a half. It's uphill, so it's positive a half. So that's how you find the gradient in general. It's always the height of the triangle divided by the width of the triangle. The tricky thing often is working out where to put your right angle triangle. So I'll just go through a couple more examples in different scenarios so you can see how it works, and then you should get the hang of it. Alright, I'll leave the definition of a gradient up there because we'll keep coming back to that. And we'll try one that goes downhill this time. Something like that. So that's the x-axis and the y-axis. And let's say it crosses the y-axis at 5 and it crosses here at the x-axis at 5 as well. These are not to scale particularly. You don't need to measure anything. You're just using the information they've given you. Now, I could potentially draw a right angle triangle that sits in the middle here, but I've kind of got a ready-made right angle triangle here, and very often that is the case. The axes often form a nice right angle triangle for you. So the height of the triangle will be down there, the width of the triangle will be across here. So I can just use that without having to draw another right angle triangle. Any right angle triangle will do. So in this case, the height of my triangle from 0 to 5 is just going to be 5. The width of the triangle, again from 0 to 5, is just going to be 5. So the gradient of this line is the height, which is 5, divided by the width, which is also 5, except, and this is where you need to be very careful, it's going downhill So your answer here is going to be negative, whatever that works out to be. So 5 divided by 5, well, 5 divided by 5 is 1, and it's negative, so your gradient for this line is going to be minus 1. Alright, so let's try one more. Now, this technique of finding the gradient is used quite a lot in science. When you do an experiment in science, you collect some results, you normally put them into some kind of table, and you use that table to plot a graph. Once you've plotted the graph, you can find an equation based off the graph, and that will let you conclude something interesting, hopefully. So you might discover that E equals mc squared or something. But you're trying to get equations most of the time when you do experiments that connect the different variables you're looking at. And a key part of that process is finding the gradient of your line. Once you've got the gradient, you can use that to find the equation, which is what you're really after. So just as an example again, imagine you've done some kind of experiment in science, and you've got a set of results. Now, when you do experiments in real life, the results don't normally sit on a nice straight line. You'll end up plotting like a scatter graph, and the points will be scattered around. So maybe you got some results that looked something like this. So broadly speaking, you can see it's a straight line. They're not exactly on a straight line, but you can draw a line of best fit. So maybe it's something like that, kind of. And you want to find the gradient of this line. Now, it doesn't go through any nice points. There aren't any easy ways to draw your right angle triangle. And in general, in real life, when you do this, you just draw your right angle triangle wherever you like. Try and make it as big as you can. The bigger the right angle triangle is, the more accurate it will be. So if the line crosses the axis, I'd usually start here and then go kind of as far as I can. So let's imagine you go to that sort of point there from the axis like that. So this is going to be my right angle triangle. As I say, you just draw it on, doesn't really matter where it is. Then you look at the different values to work out the height and the width of your triangle. So let's imagine here that was 20, and if the top of your triangle, maybe that went up to 80, for example. Obviously this is 0 down here, so it starts at 0 on the left, and on the right, I don't want to run out of room here, let me just extend this slightly. Imagine this comes down to, I don't know, 12 or something. So you'd be plotting the data, so you'd have scales on here anyway, so then you're just going to be reading off the values on the scales. So again, we need the height of the triangle, which, be careful, is not where the top is, it's not 80. It's the distance from the bottom of the triangle to the top, which is 20 up to 80. So the difference between 20 and 80 is 60. So the height of this triangle is going to be 60. The width of the triangle from 0 up to 12 is just going to be 12. So now I can work out the gradient. M is going to be 60 divided by 12. And just be careful, this is uphill, so it's positive. We don't need to put a minus sign. But you must always check. If the line goes downhill, you must stick a minus sign here, because your final answer, your final gradient for a line that goes downhill will always be negative. Let's work out what we've got. So 60 divided by 12 is going to be 5. So the gradient of this straight line would be 5. In real life, you could then use this to find the equation of the straight line and then connect the various things you're measuring to see if there's some relationship between them, which is the point of doing science most of the time. So hopefully that's given you a good idea of how you find the gradient of a straight line. Remember the definition, that's the most important thing. You draw a right angle triangle that sits underneath the line somewhere, and the gradient is always the height of that triangle divided by the width of the triangle. Just remember, uphill is positive, downhill is negative.